Hello. For this video, we're going to investigate a problem that involves bearing, distance, speed, and time. The problem reads, a sailor leaves a port and travels at a speed of 60 miles per hour. He takes a course of south 15 degrees east for 30 minutes and then adjusts his course to south 20 degrees west for 30 minutes and arrives at an island. Part A reads, how many miles did the sailor travel from the perspective of someone on the ship? Now, to answer this, we need to consider the concept of perspective. And when someone is on the ship, the person views the ship's trajectory as the distance that is traveled in real time. So what we would need to do in order to answer the first part is to consider the total distance that is traveled. Now, we are not given this total distance directly in the problem, so we're going to have to derive it. And fortunately, we're given the speed that the ship is traveling, as well as the time that the ship travels for each section of its course. So if we have that information, we can use an equation that is distance is equal to rate times time to help us answer this particular question. Now, another word for rate is speed. So what we would need to do is, consider the speed that is given and plug the speed into the value of R, which is rate. Now, for time, we cannot plug that one in directly because the time is in minutes and the speed is in miles per hour. In order for us to plug the time in, we need the time to be in hours. So in order to do that, we're going to have to perform a conversion. So we would take the 30 minutes and we would need to multiply that by 1 hour per 60 minutes. In order to do that, we will put the 30 minutes over 1. And then we would cancel out these minutes here because we can cancel out that diagonally when we multiply. And we would multiply 30 times 1, that gives us 30. And 1 times 60, that gives us 60. And then the hours, we can put that on the side because we're still multiplying it to the fraction. So it doesn't matter if it's in the numerator or if it's on the side. It gives us the same result. Then we would simplify the fraction 30 over 60. To do so, we can find a number that divides into both 30 and 60. One number that we can use is 30. So 30 divides into 30 one time, 30 divides into 60 2 times. So we end up with 1/2 hour. So the amount of time that the ship takes for each part of its course is 1/2 hour. So we can plug 1/2 into the formula for T, and we multiply 60 by 1/2. To do so, we can put the 60 over 1, and we multiply 60 times 1, that gives us 60. 1 times 2, that gives us 2. So it's like 60 divided by 2, that actually equals 30. So the distance is 30, and now we can just add the distance for one part of the course to the distance to the other part. Now the ship took the same amount of time to travel the second part of the course. So we expect the distance to be exactly the same because we could just plug in the same values into this formula and we'll get the same answer for the second part of the course as well. So now we just add the distance for the first part of the course, which is 30, plus the distance for the second part of the course, which is 30, and we end up with 60. And the units are in miles because the speed is in miles per hour. and then we're asked for how many miles. So we really can just say it's 60 miles. All right, so that's how we answer part A. So now let's check out part B. How many miles would the ship have to travel to get from the island back to the port? What bearing would the ship have to take? All right. So to answer this part, first, since we need to know how many miles the ship will have to travel to get from the island back to the port, um, well, we're not given any information concerning the amount of time that it took to get from the island back to the port. So we're going to have to try to see if we can find this distance using another method. And one method is to just make a triangle. So what we would do, like if we're trying to like draw out the triangle, we can use this particular like cross symbol here, and we will consider that that like the north is like going straight up. So if the north is going straight up, then south is going straight down. West is going straight to the left, and east is going straight to the right. And we can just consider like the information that's given. So we know that the course is south 15 degrees east. So south 15 degrees east is in this direction here. We would just make this angle that's 15 degrees, and then we can just draw the line out here. So that's how we would end up with this particular line. And then we have south 20 degrees west. So from where we ended, we can draw another cross, and then we would just put 20 degrees right here, and we would go south 20 degrees west like that. So we have just two lines at first, and then we need to determine the number of miles the ship will have to travel to get back from the island back to the port. So we can just connect it with this third side. So we end up with a triangle. So the ship goes this way first, then this way, and then back to the port. All right. So now what we would do, like when it comes to like information that we need to fill in, if this is 15 degrees here, we can actually infer that this has to be 15 degrees. And the reason is because they are alternate interior angles. Now, this is a concept from geometry where if you know that this line is parallel to this line here, like if we're dealing with two parallel lines, and then we have a line that intersects both parallel lines, that line is considered to be a transversal. And really, if you know what the measure of this angle is here, you can get the measure of this angle and the fact that it is congruent to the first angle. So both of these angles have to be congruent. So if we know that this angle is 15 degrees, then this angle also has to be 15 degrees. Also, we know that since we're given the distances for these two sides, we can go ahead and put them. So we know this is 30 and this is 30 as well. So we have 30 here and 30 there. And then what we need to do is try to see if we can use any properties of triangles to find the third side. And one property that we can use is called the law of cosines. So with the law of cosines, if you know two sides and the angle between those sides, you should be able to determine the third side. Now, to find the angle between the sides, if we know that this is 15 degrees and we consider that these lines here are perpendicular, we see that they must intersect at right angles, and a right angle has a measure of 90 degrees. So if this angle is 15 degrees, then we can subtract 90 minus 15, we get 75 degrees. So this angle has to be 75 degrees. And then likewise, if we know that this angle is 20 degrees, then we can subtract 90 minus 20 to get 70. So this angle here is 70 degrees. And then to get the entire angle of the triangle, we just add 75 plus 70. That gives us 145 degrees. So this entire angle of the triangle is 145 degrees. All right, so now we have enough information here to use the law of cosines. So we can set up the equation. C squared is equal to A squared plus B squared minus 2AB times cosine C. So this is one of the equations of the law of cosines. And if necessary, we can label the angles A, B, and C. The side C is opposite of the angle C. The side A is opposite of the angle A, and the side B is opposite of angle B. So we're trying to find this side, which is side C. And we see that angle C is 145 degrees. So we're going to plug in the 145 degrees for the angle C that's here. Side A is opposite angle A, that's 30. Side B is opposite angle B, that's 30. So we'll plug in 30 for A and then 30 for B. So overall we're plugging in 30 for A, 30 for B, and then 145 degrees for capital C. And after we plug it in, of course, if we want, we can simplify it. And then if you have a certain calculator that allows for you to put everything into the calculator at once, we can do so. But if not, then of course you would just have to follow the order of operations to simplify this. But if you put everything into the calculator, we should end up getting this particular decimal, 3,274.47368. And that is actually what C squared is equal to. Now, to cancel out the square, we're going to have to take the square root. So really, we can view this as taking the square root of both sides. Now, we only need the positive square root because only positive values for side C make sense in this case. So we take the square root of this and it cancels out the square like that. And then we're able to determine what C should equal. So C is equal to 57.22301704 approximately. All right, so that is actually what we're looking for when it comes to the number of miles the ship will have to take to get from the island back to the port. If we want to, we can go ahead and just write that out. So that's like 57.2 miles approximately. Okay, and that is the answer to this, well, to the first question of this particular part. All right. Now, we need to determine the bearing that the ship will have to take. All right. So with the information that we have, let's see, we can actually go ahead and figure out like what this particular angle is. Like if we make this particular cross here, it helps us determine the bearing. And then like the bearing that we're looking for is up here. But to find that, we need to know what this angle is and what this angle is. To determine what this angle is right here, we can just use alternate interior angles again. So this angle is 70 degrees here. This angle also has to be 70 degrees. Now to determine what angle B is, we can use another property of triangles referred to as the law of sines. Now the law of sines goes like this. If you have the sine of a particular angle over the corresponding side, it is actually equal to the sine of like any other angle over its corresponding side. So sine of A over A is equal to sine of B over B, which is equal to sine of C over C. And really, we can form an equation if we just know, like, if we just um if we just have information for two parts of this particular formula. So here we're trying to figure out what B is. So we need this part because it contains the variable that we're trying to find, which is capital B. And we already know what this angle is here. So we know what angle C is, and we know what side C is as well. So we can plug that into this part. So we just need this part and this part. So we don't really need the first part, so we can actually do away with it. So now we just plug in what we know. So side B is 30, so we can plug that in. Capital C is 145 degrees. Side C is 57.22301.704. So now once we have done that, we can go ahead and solve for angle B. The first step that we can take is multiplying both sides by 30 to cancel out the 30 that's in this denominator. So basically it's like 30 times this and then this times 30. These cancel out because we're multiplying 30 to the entire fraction. Then we're multiplying this by 30. And we get sine of B is equal to 30 sine of 145 degrees over 57.22301.704. Now, if we want to get B by itself, we just need to consider that we're taking the sine of B here, so we can't divide both sides by sine um, because it's actually a trig function. So if we want to get B by itself, we're going to have to use the inverse sine, which is really the inverse trig function of sine. So to set that up, we'll just put the angle on one side, and then we'll just set it equal to inverse sine of whatever was on the other side. So it's the inverse sine of this particular expression. And then if we want to, we can just put this into the calculator. We just have to be careful to make sure that our calculator is always in degree mode. Because if it's in radian mode, we're going to get the wrong answer. So we need to make sure that the calculator is in degree mode. And then once we put this into the calculator, we get B is equal to 17.5 degrees. So we can put 17.5 here. Now we're ready to find this particular angle. So once again, we see that we're dealing with a right angle, which has a total measure of 90 degrees. So we could just take the 90 degrees, subtract the 70, and then we would have to subtract the 17.5, and that will give us 2.5. So that is 2.5 degrees. So we end up with this angle being 2.5 degrees. Now, this angle will help us determine what the bearing is because it looks like it's coming from north. So it's north and it's 2.5 degrees east. So we can go ahead and write that out. So that is north 2.5 degrees east. So yeah, so that is our bearing.